Hello, welcome back to Algebra 1. Here we're finally going to conquer the concept of dividing real numbers. So we've learned how to add real numbers, meaning negative and positive numbers. We've learned how to subtract them. We've learned how to multiply them. And now we're going to learn how to divide them. And in fact, the rules for division, as far as the signs go, are the same as for multiplication. So for instance, if you have a number A and a number B, and you want to figure out what A divided by B is, or the sign of A divided by B, it's a very simple process. And you just have a couple of cases to consider. If you have both of them positive, you're going to get a positive. If both of them are negative, you're still going to get a positive. And if this one's negative and this one's positive, you'll get a negative. And if this one's positive and this one's negative, you'll get a negative. Now, the reason why I flew so fast through that is because it's exactly the same rules that we had for multiplication. Basically, if the signs match, you're always going to get a positive answer. And if the signs don't match, you're going to get always a negative answer. Those are the exact same rules for multiplying numbers together. So you don't have to memorize anything differently for dividing numbers. One more thing I want to remind you of in general, remember, or I should say recall, for fractions. Remember we talked about fractions quite a bit before. We spent quite a bit of time on fractions. And I taught you that if you have a fraction and you're dividing by some other fractions, for instance 3/4, so 1/2 divided by 3/4, the way you handle that is you say that it's basically turned into multiplication. Remember we said that you multiply the first fraction times and you flip the other fraction over, so you make it 4/3. And that's how you handle all fraction division. You basically multiply the first fraction times the flipped over version of the second fraction, but now you know when you flip over a fraction it's called a reciprocal. So you see, really, I didn't say this in the last section because I didn't want to confuse you, but basically division of any kind is really the same as multiplying by the reciprocal of the number. And that's why we studied the reciprocal just a section ago or so, because really multiplying by a reciprocal is the same thing as doing division. All right, so the first problem we're going to have is negative 21 divided by 3. And so if we just follow our chart here, we have a negative number divided by a positive number. So 21 divided by 3 is going to be 7, but since it's negative divided by positive, it's going to be negative 7. And that's going to be our final answer. Now we're going to crank through a few of these problems, and then I'm going to show you something interesting at the end. All right, what if you have 0 divided by 4? Well, actually, it's a little bit of a trick question. When you have 0 divided by anything, you always get 0. So that's just kind of something I want you to kind of keep in mind. When you take something like a 0 and divide by anything, you're always going to get 0. It's neither negative nor positive. What if you had something like negative 25 divided by 5? So you have a negative number divided by a positive number. So first you divide the numbers. 25 divided by 5 is 5. Negative divided by positive, since they're opposite signs, gives you negative 5. So that's the answer there. What if you had negative 6 divided by negative 6? Again, 6 divided by 6 is 1, and since it's negative divided by negative, the signs match, the answer is going to be positive. So the answer actually is positive 1. All right, what if we had negative 2 divided by 2? 2 divided by 2 is 1, and since it's negative divided by positive, we get a negative, so the answer is negative 1. Cranking through this, what if we have 49 divided by negative 7? Again, you divide the numbers. 49 divided by 7 gives you 7, and since the signs are different, it's actually going to be negative 7. So the rules are exactly the same for multiplication. That's why we're able to go through this so quickly. And what if you have 2 divided by negative 8? Now this is a little different. You can't do the straight multiplication here, but you can simplify this fraction, right? What do you do here? You have, on the top, you have 2/8. How would you simplify this, right? You have a negative 8 on the bottom. You can divide the top by 2 and the bottom by 2. Divide the top by 2, divide the bottom by 2, and so what you get on the top, 2 divided by 2 is 1. On the bottom, negative 8 divided by 2, what is negative 8 divided by 2? It's negative divided by positive is going to give you negative 4. Okay, so since the negative sign is on the bottom, when you have a fraction with a single negative sign, the negative sign can float out in front like this, so you can write it as negative 1/4. So you see, you needed to know the rules of division in order to know how to simplify this bottom part, because negative divided by positive gave you that negative here. So these are all of the problems I really wanted to show you in this section, and really we're just following this chart. If the signs are opposite, you get a negative sign. The signs are opposite here, you get a negative sign. Here the signs were the same, you get positive. Signs were different, negative. Signs are different, negative. signs are different, also negative. So we're basically done with the problems, but I want to point something out to you here. You see, because anytime you really divide something, it can be thought of as multiplying by the reciprocal. And I just want to show you that real quick. You don't need to know this to solve the problem. I'm just trying to go just a little bit deeper for you. So for instance, for this first one here, the negative 21 divided by 3, you can rewrite that division as negative 21. You can rewrite it as multiplication by the reciprocal of whatever's on the bottom. What is the reciprocal of 3? It's 1/3. So this division, negative 21 over 3, can be thought of as the top multiplied by the reciprocal of the bottom, which is now a fraction, 1/3. Now if you look at this, you see that it's exactly the same as what you started with, because the 21 times 1 gives you this, and then the implied 1 here times the 3 gives you this. So whether or not you think of it as division or you think of it as multiplying by a reciprocal, you're going to get the same answer either way. Now also, this explains why all of the rules are the same for the signs for multiplication and division of numbers, because all division really is multiplication. Any division problem that you write can be written as multiplication. So for instance, this one can be written as 0 times 1/4, the reciprocal of the bottom. 0 times anything is 0. That's why we got 0 for the answer. You can write this one as negative 25 times 1/5, the reciprocal of the bottom. The reciprocal of whatever you're dividing by, which is 5 in this case, is 1/5. So you're turning it into multiplication. This one can be written, you see the pattern here, negative 6 times 1 over negative 6. You're going to get the same answer either way. See here, if you multiply the tops, you get this. If you multiply the bottoms, you get this. It's the same thing, no matter how you slice it. This one can be thought of as negative 2 times the reciprocal of the bottom, which is 1/2. This one can be thought of as 49 times the reciprocal of the bottom, 1 over negative 7. Right? And this one here can be thought of as 2 multiplied by the reciprocal of the bottom, 1 over negative 8. Okay? So you see how any division problem can be turned into multiplication by the reciprocal of what you're dividing by. And that is helpful sometimes. And it also, again, explains why these rules are the same for division and multiplication. So follow me on to the next section. We're going to do some more work with dividing, just get a little more practice, and be on our way with learning how to apply this concept in algebra.